go. Listen. So Gavin is passing around a little piece of paper. I think that you should, it is a cheat sheet. I think that you should use it to like set up all your sequences. So I'm going to also pass around some staplers. And I would put this at the front of your packet for this week. Put it at the front of your packet. So listen up. Did you get one? Okay, awesome. Thank you, sir. So, listen. I'm not going to talk over you. Okay. So yesterday we learned how to use a geometric sequence. Someone just tell me, how is a geometric sequence different than an arithmetic sequence? Corbett.
So the geometric was like multiplication.
And
The arithmetic was addition.
Yeah, that's exactly right. So the geometric sequence uses what's called a common ratio, and you multiply to get the next term, where an arithmetic sequence uses what's called a common difference, and you add or subtract to get the next term. Okay? Does that make sense? Okay, so this is the formula that we learned yesterday. Remember that this is the nth term. And when we say that this is the nth term, that means if you read that you want the 7th term, that means you're going to plug in a to the 7 here. A to the 1 is the first term. So you'd have to get that first term from your sequence, your common ratio. But this n minus 1, you take whatever term you're trying to find, the 7th term, and you subtract 1 from that. So you would raise your r to a power of 6. Okay, so honestly, if you're using the cheat sheet, I think that you'll be totally fine. So here's what we're going to start with. I have 3 sequences in example A. Tell me what the first sequence is. Cain, 256, 128, 64, 32. So it's a geometric sequence. Okay, you don't get to do any more right now. Give it a, well, yeah, let someone else try. So r equals 1/2. Let's look at example letter A. So the second sequence, 4, 9, 12, 18. What do you think? Antoine, you had your hand up. It could be geometric, arithmetic, or neither. Neither. Good job. Yeah. There's not a single number that I can multiply all of those by to get the same term. And do you guys remember how to check that? Common ratio, the last term divided by the term that comes right before it. That's 1.5. Common ratio, the last term divided by the one that comes right before it. That's 4/3. Those are not the same. So I know that it's not geometric because it doesn't have a common ratio. And I know that it doesn't have, let's see, +5. That would be +3. That's +6. So there's no like common difference either. So that's why it's neither. Kate. Oh, Kate. Okay. 2, 4, 16, 256. Go. Is it? What am I multiplying by? Okay. 4 times 2 is not 16. 4 times 2 is 8. It's squared. It's an exponential function. It's not geometric though. But each term is getting, like, to find the second term, you square the first term. That's what's happening. Yes. Okay. That's not a multiply though. So it's not geometric. Sorry, I wrote geometric. That's not true. Yeah. Correct me. No, it's neither. Yeah. Yeah. You can correct me loudly, Daniel. Okay. Let's look at B. B's telling us that it's geometric. So it says find the next 3 terms. So the first thing that we need to do is find what? What do we need to do first? The common. Yeah, we need to find R. How do we do that? Yeah, take the last term, -64, and divide it by the one that comes before it. Thank you so much, sir. -64 divided by 16 is -4. So I have a common ratio of -4. So to find the next 3 terms, I take the last term, which was 64, and I multiply that by -4. Anyone? Oh, the last one is -64. Yes, thank you, sir. What'd you get? 256. Then I'm going to take that and multiply that by -4. And then I'm going to take that and multiply that by -4. Go ahead. 4096. So those are the next 3 terms of our sequence. So all we had to do was find R. That's the biggest thing, finding R, right? So let's do that again. So first, we need to find R. Someone tell me what I'm setting up to find R. Kane. Well, so I'm setting up what? The last term divided by the term right before it. And so we really don't divide by 3. This is a what? Multiply by 1/3. So let's take our very last term, 1, and I'm going to multiply that by 1/3 to get the next term. What's 1 times 1/3? It's 1/3. And I'm going to take 1/3 and multiply that by 1/3. Remember, when we multiply fractions, we multiply straight across, top times top, bottom times bottom. What does that equal? 1 times 1 is? 3 times 3 is? Okay, and I'm going to take that and multiply that by 1/3. 1/27. Ma'am. I didn't write anything up here, honey. Okay. That's fine. Yeah. Awesome. You finally got the what? Nice. Are we ready?
Wait, no. Okay.
Good, Daniel? Okay. All right, here we go. So we're going to find the given term for each sequence. Listen up. So when I look at example C, the first thing that I have to do is figure out what R is. That's the first thing I have to do, is find R. So I'm going to write that over the top. First, let me scroll down a little bit. First, I'm going to find R. So first, find R. And then the next thing that I'm going to do is I'm going to identify A1. Okay. R is 2. Does everybody agree with that?
Yes.
Well, I'm going to show my math because we're making a video. The last term divided by the term that comes before it is 2. Okay. What is A of 1 or A sub 1? It's -6. That means my first term is -6. I want everyone to look at their cheat sheet and give me the explicit formula for geometric sequence. Kane. A sub n equals A sub 1. Geometric sequence. You're doing arithmetic. Huh? Yeah, for geometric, I said. Okay. Yeah, R to the n minus 1 power. She just walked right all over you, Kane. I love that. Okay, listen. So here's what we know. We're writing the equation for the nth term, meaning I'm starting with A sub n. But there are some things that we can replace. Like, don't we know what A1 is? A sub 1? -6 times. Don't we know what R is? To the n minus 1 power. That is the equation for the nth term. We use the explicit form when we are trying to find the nth term. Now, what is the nth term we're trying to find? N equals 11. So that means I'm going to replace the n here and solve it. So a sub 11 equals negative 6 times 2 to the 11 minus 1 is 10. Okay. So in your calculator, you have to take negative 6 times 2 to the power of 10. What'd you get? Perfect. That's perfect. Okay. I did. There are 2 boxes up there. Okay. You're right. Next one. So same thing. We have to find R. Gavin Kane, tell me what 2 numbers am I dividing to find R? No, tell me what 2. I'm writing it out. Tell me what 2 numbers do I set up to find R? 9 divided by 27. Turn it into a fraction. Very good. So, what's the first term, Amira? What's the first term? 243. So let's write this equation. So A sub n. Yeah, go ahead, say it. To the n minus 1 power. Make sure we know that we're raising that to a power. Awesome job. Okay, what's the nth term we're trying to find? N equals 17. So do you want this one as well, Amira? Go ahead. A sub 17. And 17 minus 1 is what? Good job. So here's what I would do in my calculator. I would take 1/3 to the power of 16 first. So parenthesis 1 divided by 3, close your parenthesis, raise it to the 16th power, and then multiply that by the 243. Yeah, it's crazy. How many zeros are there? Aren't there like 5 zeros before you even get any numbers? What do you have? Yeah, I don't think that's right. Hang on a second. 1 divided by 3 to the 16th power times 243 is like 0.00000. Didn't I say aren't there like 5 zeros? Okay, show me what you did in your calculator. Did you put the fraction in a parenthesis like I said? Oh, do you see how it has e to the negative 6? Do you not know what that means? No, I don't. Okay, let's talk about that really fast. This is a great question. Tell me what your answer is really fast. Give me just the first 5 numbers. 5.645. E to the negative 6. This is scientific notation. I've never even. Okay, so hang on. This is how a calculator represents the amount of zeros in there are so many that I can't show you what that number is. So because this is negative, it says take this decimal and move it to the left 6 times. 1, 2, 3, 4, 5, 6. So I have to fill this space with zeros. What? Yeah, which is exactly what I got on my calculator. Okay. We're almost done. Okay, but we are going to do an example. I'm going to do some of your homework with you. Okay. All right. Okay. Stop whining about how much homework or how many notes we're going to have, and let's get. Shh, I was talking right here. What? Yes. Shh. Who didn't have it written down? Are you done? Okay. Okay. All right. A culture of bacteria doubles every hour. So if I have 2 pieces of candy bar or 2 pieces of candy and I double that, how many do I have? And then if I take that and I double it, how many do I have? So what is the value of R? How do we double something? We do what? Multiply by 2. Okay. It says the culture started with 250 bacteria. So what does that mean? No. What does that started with mean? What does that represent? The first one, A sub 1. A sub 1 is 250. Okay. So we have, listen. I'm going to just change the homework and give you all of the questions for the next 4 pages. Then shut your mouth. I'm not going to ask you again. So write the explicit equation. So I want an equation for the nth term. Eli, you 3 figure it out. Use your geometric sequence notes, right? That little cheat sheet that I gave you. You know what your A1 is, and you know what your R is. Am I speaking French? A sub n. Awesome. To the power of. Awesome job, Eli. Okay. So that is the explicit formula. So we have to create a table. And remember that n is an integer, whole numbers, right? And we always start n at 1. So we can't fill up the 0 yet. We just can't. But when n is 1, we know that we have 250 bacteria. And then when we do it again, how many do we have? 500. And then when we do it again, how many do we have? I'm doubling it. 500 times 2 is 1,000. 1,000 times 2 is 2,000 times 2 is okay. So let's check and see what the amount of bacteria would be after 7 hours using our equation. 8 to the 7th. How many bacteria would I have? Kane, how'd you do that? Okay, so 250 times 2 to the, what is 7 minus 1? 6th power. 2 to the 6th power is 64. 64 times 250 is 16,000. So if we were to just graph these points, the first ones would be really low, right? Like really small down here because we have 250, 500. We don't hit 1,000 until 3 hours. And then at 4 hours is when we finally get to the 2,000. At 5 hours, we get to the 4,000. At 7 hours, we're going to jump up to 16,000. The question is, when do you think it's going to reach 15,000? How are we going to do that? Well, we could just keep doubling. After 6 hours, how many do I have? 8,000. And after 7 hours, how many do I have? So somewhere between 6 and 7 hours. Okay. So what's that last question say? Use this formula to find out how many bacteria will be present after 1 day. So go ahead. What were you going to say? 1 day is 24 hours. So what term am I looking for? A to the 24th. So my formula that we wrote was a to the n equals 250 times 2 to the n minus 1. So Antoine, plug that in. Tell us what it's going to look like. 2 to the power of 23. Yeah, good job. So I don't know if my calculator will go that high, but we're going to try. It does. Anyone? What are we getting? Shh. 2,097,152,000. Okay. 2,097,000,000. That's almost what the lottery is, right? Nice. Okay. So, questions. Okay, let's look at our homework. We are done.